Okay, welcome back. I guess I should say again, this is the third page of Chapter 3, 4B, and we'll go through this on a nice real-world problem here. Here we have a monthly profit in thousands of dollars. Boy, I can bet that's going to come back and haunt us if we're not careful. Of a software company is given by this, where X is the number of software packages sold. Okay, so if we're going to graph this guy, this is most certainly intended to be a graphing calculator type problem. I kind of like to figure some good values here. In fact, B says what values make sense in the problem situation. Well, for sure, X should be greater than or equals 0, and I kind of like to think of that stuff before I finish my graphing work. On the calculator, I've got a formula. In fact, I've got a couple formulas put in here so you can see I'm loaded for this first formula, and then later on they're asking us to use nderive to find the derivative graph of P. So I've got that guy loaded as well. But let's give some thought to B first, because otherwise we're just kind of doomed to going zoom standard and then zoom out, zoom out, zoom out. If we can figure out our values of X and use zoom fit, we'll be in pretty good shape here. Now, as X gets really, really huge, let's consider this for a minute. As X gets really huge, I get 5 minus a really huge number, or 2 to a huge negative. And as I get 2 to a huge negative, 2 to a huge negative is 1 on 2 to a huge positive, and that's approaching 0. And 0 times 50 is approaching 0. Plus 1, we're just approaching 1. We're approaching 10 on this graph when we zoom fit this thing, when X gets huge. So, but what value of X is huge? For the purposes here, I played around with this a little bit for some values, and it seemed like 200 was a reasonable value to go to. If we're thinking in terms of the story problem itself, monthly profit of a software company is given by, I don't know, how long is our software company going to be in existence? If it's in existence for 5 years, then X maybe greater, or maybe X should be less than or equal to 60 since it's monthly. But I put in X is less than or equal to 200. There is not, and again, trust me, I got that by looking at the graph. So if we go into our Y equals, then we go ahead, we graph we set our Y1 equal to the original function, and we set our Y2, because of question C down here, might as well get that out of the way too, to our derivative of, where did I get the Y1? From our vars key. So when we get down into this point right here, I would just go vars function, select Y1. Notice we're going X to X. We're not looking for a specific value. I want the whole function that fits. And then if we go zoom fit, we end up with this graph right here. This is the original function. Oh, it does level off, and again, 200 doesn't necessarily mean that's the best, but we do see that leveling off. I don't know why I'm saying that's 200 at X equals 200. If I trace this guy and run out here, our X values, did I get that wrong when I was talking about that earlier? Our Y values do appear to be approaching 10, and obviously our X value is going to get close to 200. That's what we set. So again, a little bit arbitrary here, but I definitely would say 0 makes sense for our left bound. Right bound 200 just seemed to fit most of the interesting portion of the graph. So I'm kind of jumping around here a little bit. In fact, we kind of talked about F already. What's the limit? If I want the limit of 10 on 1 plus 50 times 2 to the 5 minus 0.1x as h, it's not h here, that would be as x approaches infinity. It's big X test. Again, what happened? I get 2 to a big negative, which becomes 1 on 2 to a big positive, which becomes 50 on 2 to a big positive, which becomes 0. So this thing becomes the limit as X approaches infinity of 10 on 1 plus 0, or 10. What is the maximum profit possible? What do you suppose? $10? Nope, I said this might come back and haunt us in thousands of dollars. So $10,000. Okay. They better not be employing too many people. Oh, that's monthly profit. It better be a pretty small company then. If 2 people are working there, they're each making about what's that monthly profit? They're each making about $60,000 a year. So small company, I'm hoping. All right, so let's go back, and I'm just going to put our graph down here. They asked for the graph, so I'm just going to get a rough copy of that guy. So it hugs along 0. Kind of makes sense. If we don't produce anything, we're not going to make anything. We've determined already that's about 10. We've determined already somewhere in here is about 200. And again, that's just kind of to work off of. Okay, what values of x make sense? We've got it. Use nderive to graph p prime. And we've done that. And it's way down here. Stays pretty low, but we see it kind of bumps up. I'm not sure exactly how far that is over, so let me jump down trace just out of curiosity, really, for right now. We may take a closer look at this. Over at about 110. Oh man, it might be right at 100. Could be somewhere in there, about at 105. So about at the halfway point, this kind of hugs along and just pokes up a little bit. That's probably too far down the road, but anyway, we got a graph look something like that. For what value of x is p relatively, for what values of x is p relatively sensitive to change in x? Well, it's not relatively sensitive here, but again, relatively is, that's a little bit arbitrary, but I would say as we're getting steep, somewhere in this range as we go through our steepness. So our calculator tool that might help us most there, you could look at a table, but I sure like going back to trace. So I could say, well, it doesn't look until we get to about right here to be relatively sensitive. I mean, it's pretty flat, and then it really starts getting steep. So maybe around 70 or so. For what values of x is p, that's our profit function up here, relatively sensitive to changes in x, would be about maybe 70 is less than x is less than, and it continues to be really, for certain we would be talking about this area. And we mentioned cupping earlier in this video a little bit, or in the previous video to this. We are cupping up, and then at some point right through here we're cupping down, which means we hit our steepest point. So for sure we should be talking about values right in here. But it's still pretty steep, and then, well, it starts to settle down, maybe 140. And again, there's some arbitrariness to that. Okay, what is the profit when the marginal profit is greatest? Marginal profit. Now, back to business definitions. We had a problem from the first worksheet from 3-4, where we were given a marginal cost equation, we were given a marginal revenue. You may remember that guy. We were given our marginal profit, marginal cost, but now we're just given a monthly profit. So that profit, that is our revenue. So let's go back and we see that our marginal revenue, how much we make, is just the first derivative of our function. So I want to find p prime of x here. So I need the derivative of this guy. What is the profit when the marginal profit is greatest? And I would have to go through, if I was doing this by hand, finding the derivative of this. But my blue function is the derivative of this. And the marginal profit is greatest right here, and that truthfully should be right underneath that cupping point. I said earlier I probably drew that too far down the road, but it should be right underneath that cupping point when the slope is the steepest, because this is a representation of the slope. Does that make sense? Okay, so this one, we're not going to do it by hand. We're going to go back to our calculator, and what I want to do is find out when my derivative, my marginal profit, is the biggest, when this graph is the steepest. So I'm going to jump down onto this function, and I want to find somewhere right around in here, but I'm not going to guess at it. I'm going to go second, calculate, maximum. Make sure I'm going to jump down onto this guy. Make sure I'm to the left of that maximum. Enter. Make sure I'm to the right of it. Enter. Guess. Nope. Tell me what it is. And we've got when X is 106. So, what is the profit when the marginal profit is the greatest? Well, what we've got right now is this is the point about, well, not really, well, I guess about, but boy, this is pretty accurate. 106.43861. This is this and some Y value. So what I want to do there is I want to find what the profit is at, I want my profit at 106.43861, and I could take that value and put it back into my profit equation. Or I could just go, I just bumped up here. Notice I went from this value here, I bumped up here, and we were at 5.000000082. And this may be wrong. 5 might not be the best value, but I got a sneaky suspicion anytime that we're that close to an integer, it might be an integer problem. And there's something about looking at this that seems like, yeah, 5 might be a player in this equation with this 10 and this 50. So I'm going to say, what is the profit when the marginal profit is the greatest? That would be 5, but 5,000, or 50,000 actually, excuse me, 50,000. This is in tens of, nope, it's just in thousands. Getting this problem mixed up with another one. So $5,000. What is the profit when the marginal profit is the greatest? Which means the next month it goes, yeah, it's still creeping up higher. In fact, not creeping, it's still getting, the profit's getting higher, and they don't reject that. But the marginal profit at that instance, it's at its steepest. Our derivative is the steepest it's going to get. Now, what is the marginal profit when 50 units are sold? This is just calculator exercise now. The best way I believe to do this would be, we're going to go into our calculator here, and I'm just going to go second calc value. Find the marginal profit. So which function are we going to be looking at here? The marginal profit at 50 units. What is the marginal profit at 50 units? So we want to jump down onto this function, and we're going to find, I'm going to go second calc, and I'm going to be just looking for some values here. Second calc, try that again, second calc, I don't know why I'm not getting to value here. Second calc, there we go, value. And I want to find the value at, so that's our marginal, so this is P prime of 50 equals, I'm going to adjust this in just a minute, but 0.196078, and then I'm going to do P prime of 100. Nice thing on second calc value is now all I have to do is just enter 100, hit enter, and I get 3.902439. But that is times 10,000, and we get 10,000. Am I still doing 10,000? Just 1,000. Just times 1,000. Sorry. And I get 3 decimal places moving. 1, 2, 3. I get approximately $196.08 times 3 decimal places, $3,902.44. And we would just continue that with 125. So we've got, I'm just going to answer these more directly. So I'm still in second calc 0, and I want 125. Enter. So P prime of 125, move the decimal 3 places, I get 7835.68 dollars, and P prime of 175, So 175 in the calculator, and we've done all the heavy lifting here, is $9914.42, and P prime of 300. Don't have 300, so window, gotta quit. Gotta go back to my window here and extend out beyond 300. I'm gonna go 301. Take a little bit of time to graph this perhaps. Still trying to graph the derivative. I may have wanted to turn that one off. So again, what do we notice is this is finishing up. Our steepest point is right above our highest point of our derivative. And we're done there, so back to second, calc value 300. And I get 9.99999, so this is P prime of 300, 9.9999, comma 999 point. See, we got that 9? My eyes. Looks like 99. All right. So I think we just do that just to get some interpretation what's going on here. I mean, when's the company really excited? Well, sure, as months go on, we're still doing better all the time, and we're basically approaching $10,000 here, or $10,000 here. But the company's probably getting really fired up between like 100 to, you know, pretty good time frame here. This 2 years, 100th month to the 125th month, where our monthly profit jumped, like doubled, still a big increase here. And then we're like, you know what, we've reached our capacity. We're basically a company that's going to be making $10,000 per month. Okay, hope that all made sense to you. Stay tuned. Here's a look at your assignment from this section. Got to remind you, we're really going to be looking closely for words like position and velocity and acceleration, and being really careful to label our solutions. In this case, I got the dollar signs, but dollars, and we had a lot of solutions in this worksheet where we had things like meters per second and meters per second squared, and we need to have good labeling, good unit measures. So stay tuned, and we will be looking at practicing tests.